and welcome to today's lesson. I'm Mrs. Miller. Today we will explore the question, how do light rail trains slow down and stop? Are you ready? Grab your pencil and your science journal, and let's get started. Let's watch a video clip of a dark rail train. As you watch, pay attention to how the train slows and stops. That video clip makes me wonder, what could happen if the train does not stop at the correct place? Hmm. Maybe people would not be able to get on or off the train. And hey, did you notice that the train stops right in front of a covered area? The train seems to stop in the perfect spot to allow passengers to board and exit the train. Where do you think the force that helps the train slow down and stop comes from? Let's keep these questions in mind as we work to answer the question, how do light rail trains slow down and stop? Let's use our train model and some other materials to model how a light rail train slows down and stops. We need to think about how friction will affect our materials. Remember, friction is a force exerted between the surfaces of objects in contact. If you kick a ball, friction between the ball and the grass will eventually cause the ball to slow and stop. How could we use these materials to slow and stop the train model? Maybe you said we could push the train over sandpaper, or we could drag a piece of felt behind the train. Let's test these ideas. I set up this activity using what we have learned from our previous investigations. I taped down the spring scale to keep it from moving, and we have a meter stick and finish line to help us compare how far our train model travels. First, let's watch a video clip of the train model being pushed with 5 newtons of force. We won't try to slow the train down with sandpaper or felt this time. Now let's watch another video clip. We will use 5 newtons of force again, but this time we will use the sandpaper to try to slow the train model down. What do you think will happen? I think the sandpaper will slow the train model down. Let's see. The train model did reach the finish line this time, but I think it was a bit slower. And the train model didn't travel in a straight line like it did before. Let's test the felt. What do you think will happen this time? Do you think the felt will slow down the train model? Let's find out. Wow, the train model was definitely slower at that time. It crossed the finish line, but I could hear that the wheels were slowing down. And the train model didn't travel in a straight line this time either. That was a great activity. I learned so much. Did you? When we used 5 newtons of force with no sandpaper or felt, the train model traveled in a straight line and crossed the finish line. When we used 5 newtons of force with sandpaper, the train still crossed the finish line, but the sandpaper slowed the train down a little bit. And what happened when we used the felt? Once again, the train crossed the finish line, but the felt slowed the train model even more than the sandpaper did. I wonder, could friction be used to slow or stop a light rail train? The brakes on my car slow down and stop my car. A brake is a device for slowing or stopping something. A driver uses a brake to slow and stop a car. Light rail trains have different types of brakes. Some brakes on light rail trains use friction to slow and stop the train's wheels. This is a magnetic friction brake. Do you notice the arrow that shows the motion of the train? Use your finger to point in the direction the train is moving. This way, right? This bar can move up and down. How could this bar be used to create friction and slow the train? Maybe you think that the brake pushes against the rail to slow down the train. That's right. When the bar moves down, it touches the rail, which creates friction. I have a video clip from a different train that uses a magnetic friction brake. Let's watch it together. The bar is touching the rail at the bottom. And look, the bar goes back up after the train stops. Neat. Let's add an arrow to show the direction of the force of friction. Use your finger to point in the direction for the force of friction. Did you point this way? Great! Some light rail trains have a brake that uses sand to create friction. In this photograph, the train is moving to the left. This tube is directly in front of the wheel and points at the track. I have a video clip of a different train that uses a sand brake. This is the sand that the train uses for the brake system. Let's watch the video clip together. Wow, I see the tube. And look, sand is coming out of the tube. In this video clip, this tube is releasing sand onto the track, right where the wheel contacts the rail. The sand creates more friction, helping to slow the train. In an emergency, the sand can help the train stop faster. Remember our braking exploration activity? We use materials to slow and stop the train model. Was our activity like the real brakes on a train? Why or why not? Well, sand is used to create sandpaper. Both the sandpaper and the sand brake uses sand to slow down motion. And the felt connected to the train model made contact with the table to slow down the train model, just like the magnetic friction brake made contact with the rails to slow down the train. We've been working to answer the question, how do light rail trains slow down and stop? Do you think we know the answer now? I do. A light rail train slows down and stops when friction brakes increase the backward force of friction on a train. The force of friction can be from a brake, such as a magnetic friction brake, or a sand brake. We certainly have learned a lot. Let's update our class model with what we've learned. What do we need to add to our model? Brakes, right? We saw brakes close to the wheels on the train, so let's add them. Here. Should we add anything else? Oh, I know. We need to show the backward force of friction caused by the brakes. Let's add that information right here. Great. Now let's update our explanation. Let's add, dart rail trains can slow and stop using friction. Friction brakes increase the backward force of friction and can help slow and stop the train. Wow, we really have learned a lot. Your task after this lesson will be to update the class model and explanation. Let's look at our driving question board. Do you see any questions that we can answer? Point to them. I think we can answer these questions. Is there a driver? How does the train start moving? Does the train have brakes? How does the train move and stop? And how does the train stop? Do you agree? We drew a driver on our class model, so I think we can answer this question. We have also learned about how trains start moving, slow down, and stop. So we can answer all of these questions too. I do not think we can answer these two questions yet. And what about these questions? We are not ready to answer these questions either. In our next lesson, we will explore energy in light rail train systems. I can't wait. Let's review your task for today. Update the class model and explanation.